Let's go to Chapter 9, Table 1. Cross-section area of a raceway for conductors. All right. Well, here's what I need you to do. That was pretty boring stuff. You're like, oh, man, if you're going to just talk and read a slide, I mean, I'm like, I'm not just going to talk and read a slide. But I have to sometimes talk and read a slide. You got to get your code book out. You can take a look at the graphic. Open up the Table 1 and convert the language in the code book in relationship to the table. So let's take a look at the table then, and let's take a look at a slide. The table says in Chapter 9, Table 1, that if you have a single conductor in a raceway, that you can fill that raceway up to 53%. And I believe, Eric, you worked this out with Mike Coburth, and these are the actual scale. That would be 53%. I think you were telling me that 53% represented something percentage?
Yeah, it represents about 73% of the diameter of the raceway. And so if the diameter, for example, were exactly 1 inch, the inner diameter of the raceway, then the cable would be 0.73 inches.
Okay, so there's a little way of being able to know whether that wire is big enough or not.
Right.
Okay. Now, if you have 2 conductors in a raceway, Eric, can you tell us why? You get 53%, and listen, you got a round wire and a round raceway. Kind of makes sense. You know what I mean? You get 53%, if that percentage, whatever it is. But why am I limited to 31% when I have 2 conductors?
Well, Mike, if you worked out the math on that one, if you put those conductors right next to each other and made them wall to wall, right, so there was no space between them and they filled up the raceway 100%, you would have 50% fill.
So area. 1 second. If I took this conductor right here and I moved it up,
right,
so that it was wall to wall from the center of this diameter of this conductor right here, from this edge here, center raceway, I went wall to wall. Okay, go ahead. That would be what?
That would be 50% fill. Because what they're meaning there is the area of each conductor would actually represent 25% of the overall raceway, and 25 and 25 would be 50. So it gets a little confusing, but when you look at it with 2 conductors, there's a lot of empty space in that raceway.
It's the diameters of a round wire, 2 round wires and a round enclosure, that no matter what you do, you got the width of the conductors, and you can't fill up the space above that.
Right.
But if I go to 3 conductors, you can see that we're now able to take the extra space that wasn't being able to be used by 2 conductors, and we go up to 40% fill. So that's just kind of give you some insight as to why we have these different percentages. Okay, we're still on Chapter 9. We're still on Table 1, the conductor percent fill. There's an informational note. The maximum percentage of conductor fill listed is based on conditions where the length of the conductors and the number of raceway bends are within reasonable limits. Well, I'm not sure what the number of bends within reasonable limits. The code says what, guys? John, what does the code say about our bends?
360 degrees.
360 degrees. They didn't say how many bends you can have. It just simply says 360 degrees between pull points. And unrelated to this, what we're talking about is the code does not say you have to have a junction box every 100 feet or 200 feet like we've all been told all our lives. You simply have to have a junction box so that the pull points are no more than 360 degrees. Somebody's going to make something? Steve?
Yeah. What this is also telling us, Mike, is the actual allowable maximums on the code book are probably more than we really want to go. And it really ties in with, we need to remember when we're taking a test how the code relates to all this. This is what the code maximum fill is, and the code is a minimum standard. If we go back to 90.1a, the purpose of the code is safety. But 90.1b tells us basically that it's not going to give us the best installation for future use, for expansion, and so on. So it's a minimum safety standard. And that's so important when you're taking a test, is they want you to answer the test not based on what's best in the field, but what's the minimum standard the code requires.
You're bringing out a great point at a great time. Mike's going to say something here, and that is that we're balancing a line here. We're trying to tell you, this is what the code says, and that's what it says. So when you're taking a test, you better answer how the code says, not maybe how you do it in the job, but you better answer the questions on passing exam exactly what the code says. And as Steve says, well, in practical terms, however, you might not want to be following the code. Mike, you want to say something about that?
Yeah, if I follow the code in all practicality, once again, this is for an exam. We just recently pulled in a 1-inch diameter cable, and if I didn't use anything other than a 4-inch piece of pipe, it would have never gone through. And even in 4-inch piece of pipe, somebody has to visualize the weight of 1,000 feet of cable being dragged.
Okay, but what size cable were you running?
1-inch diameter.
1-inch diameter cable, 1,000 feet long.
Right.
So the friction of that,
Oh, yeah.
Horrendous.
the weight of that, you're trying to drag that. So you're saying, code-wise, one cable. You say, well, how would you run a cable 1,000 feet? Well, it was high-voltage cable because the code says what? Well, we haven't got there yet. But the code will tell you if you have a cable that you're running into a raceway, you treat that as a single conductor. And so 53% fill. So you're going to fill that thing up to, Eric, what was 53% fill? 75% of the diameter.
Right.
And he'll do the math and tell us what size raceway he could have done that, right? Which is what? 1 divided by 0.75 comes out to be like a inch and a half?
You need 0.7854 on a 53% table, so let me get that.
All right, he's gonna work that out
The other
for us
problem-
there. The point is this. You answer the questions on an exam to the code, not to what you think it should be. However, in practical terms, that's what the information note saying, hey, listen, you can follow the code, but just be aware of this.